Hey everybody, Mr. Troy here. I got a quick video for you on writing explicit formulas for arithmetic sequences. It's time for math with Mr. Troy. All right, everybody. If you haven't looked at the Khan Academy yet, this is actually going to be a little bit different than what you might be thinking. I want to write a formula that tells me the nth term in this sequence. Now, here's how this is different from what you might think. This is the first term, and the second term, and the third term, and the fourth term, and the fifth term. So you cannot use y equals mx plus b right away. Let me show you what I mean. If I wanted to start with an element, I would say, well, it would certainly start with 4, and then I'd be adding 3. So the first term and the common difference, right? Now, say I want to find the second term. How many times would I add 3? I would only do it once. And if I wanted to find the fifth term, I would add 3 1, 2, 3, 4 times. So when I add 3, I'm not going to add 3n times. I'm going to add 3n minus 1 times. 1 time less than the number I'm looking for. Because if I'm looking for this term, I haven't added 3 3 times. I've added 3 twice. Okay, so this next one would be a sub n equals negative 11 minus 2 times n minus 1. It's always going to end up being that n minus 1 thing. Now, if you write this in what you would call slope-intercept form, that's fine. But if you're going to do that, you have to write it this way. Now, the key number here is this 1. Why is this 1? Well, because our first term is 4. So if we plug in 1, it's 3 times 1 plus 1 to make 4. So you kind of have to subtract to find a y-intercept if you want to think about it in that way. All right, moving on. Okay, so you'll have questions like this. Carlos and Anna were asked to find an explicit formula for this sequence. Now, you're going to want to do 2 things when you're looking at the sequence. You're going to want to figure out what is the common difference. So in this case, that's plus 6. And you want to figure out where you start. Now, for this one, they both are working with the correct common difference, 6. And they both have this idea at starting at negative 10. But remember, if your first term is plugged into this, we would have negative 10 plus 6 times 1. If we plugged in for our first term, we would get negative 4. And that's not our first term, that's our second term. So in order to correct for that, we need to do n minus 1. Because at the first term, we haven't added anything yet. It's not until we get to the second term that we've added something. All right, I hope that video was helpful. Not too tough, kind of fun. See ya.